Hello students, this is the new topic. Today I am going to start a new topic that is called locus. So important part for coordinate geometry. So locus, this word is derived from Latin word. The meaning of locus in Latin is place or location. Literally I can say that the meaning of locus means a place or a location. So but what is the meaning in coordinate plane? A locus is a collection of points whose position is represented by certain conditions. A locus is a collection of points whose position is represented by certain conditions. For example, this is a fixed point on the plane, say O, and this is a variable point, means it is moving. This position not fixed, it is moving. The point is moving under conditional conditions. For example, one condition is the point is always 2 centimeters from the fixed point O. 2 centimeters from always the fixed point O. 2 centimeters. What is the movement of the point? What is the path of that point is said to be its locus. Obviously, I can say that its movement is nothing but a curve, which is nothing but a circle. So locus of P, I can say circle. Locus of P is a circle. So what is the meaning of this? Locus is nothing but set of points which are satisfying given condition or conditions. For example, here P is the one point. So P is moving on the plane. What condition? It is always 2 centimeters from this fixed point. Always 2 centimeters from fixed point. Such a way that P is moving. The set of all those points which are satisfying given condition or condition is called locus. Or another way I can say that the path of a point, P is moving on the plane under a condition or conditions. Its path is called its locus. So what I can say, locus of P is nothing but a circle. That's why a locus is a collection of points whose position is represented by certain conditions. Or another way I can say that locus is the set of points which are satisfying given condition or conditions. Okay. Or another way you can say that locus is the path of a point which is moving on the plane under condition or condition. This is the best example. Locus of P is a circle, or in other words, the locus of point which is equidistant from a fixed point is a circle. Like that I can write the locus of a point, say P, which is always equidistant from fixed point, always equidistant from a fixed point. Point is a circle. Is a circle I can write. So this is the definition of locus, and this is one of the example for the locus. One more example I will observe students. Yeah, a straight line is given. Straight line, its position is fixed. So the question is, find the locus of a point which is equidistant from the line L. Find the locus of a point which is equidistant from L. Means we want to identify the points on the same plane which are same distance from L. The equidistance, let it be distance is taken as some D or something 3 units. Okay. First of all, I can locate a point here first initially, so that the distance is 3. What is the meaning of the? I can locate here one more point, here one more point, here one more point, here all these points are 3 units from L. All these points are 3 units from L. So what is the set of points? Here set of points giving a straight line which is parallel to given line. So what the locus of that point means, I can say a straight line. But not only one straight line. Observe here. Here also one more point exists. So that here to here 3 units. Here to here. So like that. You get infinitely many points here also. Means what happened? All these points will satisfy the condition. All these points will satisfy condition. All those 2 points gives a curve which is a straight line. So what the locus means? I can say that locus is nothing a pair of straight lines which are parallel to given line L and equidistant from the line L. Means the distance from L to those lines are 3 units. Okay, I will write that. The locus equation of a point which is equidistant from a fixed line is a pair of parallel lines. Pair of parallel lines. Okay, this is the locus. More generally, you can say a pair of parallel which are either side of the L. Okay. So one more example, students. For example, yeah, two straight lines are given which are parallel to one another. For example, they are parallel to one another. Say this is the line L. Say this line is M. These two are parallel fixed lines. Now we want to find locus of a point which is equidistant from LM. Equidistant from LM means that point should be same distance from L and M. Okay. Between this, for example, this is one of such point. So this distance is say D. This also should be D. Here this is D means this should be D. Like that, P is moving. Or such point you can collect on the plane. So all these points are satisfying in condition. What is the condition? All these points are equidistant from L and M. So what will form all those points? Will form a straight line. So that straight line is called locus equation of the point P. I will write that. The locus equation of the locus equation of a point which is always equidistant from two parallel lines is, what is that, Nana? Another line which is parallel to both is a straight line which is, simply here is a straight line you can write. More generally, which is parallel to L and M and between them. Okay. So one more example, interesting example. Two fixed points are given on a plane. Two fixed points. Now we want to find locus of another point, or locus of a point which is equidistant from A and B. Equidistant from A and B. That should be same distance from A and B. Already this concept completed for us. So the locus of point which is equidistant from two fixed point. One of the point is this, one of the point is this. So that this distance is equal to this distance. Through P, draw first of all join AB. Through P, draw a line perpendicular to AB. So every point on this line L is satisfies given condition. What the condition? The point should be equidistant from these 2 points. Easily can prove. For example, this is one of the point P. Join PA and PB. Join PB. So these two triangles are congruent triangles from SS congruency or RHS. SS congruency is better because already P is midpoint, no? PA equal to PB, and so what is, I can say this is say 1 of P or P1, I can say, okay, AP1 equal P1B. So this 90 degree common. SS congruency, these two triangles congruent. From that what will get, Nana? PA equal to PB only. What happened? P, the point P is equidistant from A and B. Take one more point here, Q. Same reason. You can say that these two are congruent. QA equal to QB. Means what is the meaning of that? Every point on this line is equidistant from A and B. So the conclusion is important here. Important conclusion. The locus of a point which is equidistant from two fixed points is very important result. Fixed point is perpendicular bisector of the line joining given points. Okay, what is the meaning of that? If 2 points are given, what is the locus of a point which is equidistant of these 2 points? Means you need to join those two. You need to draw perpendicular bisector. Every point on perpendicular satisfies the condition, and no other point will satisfy condition. That's why the locus is nothing but perpendicular bisector of the line segment joining those 2 points. Okay. Actually, to prove this theorem, we need to prove 2 ways, Nana. First one is, what should prove? 2 points are given, join them, draw the perpendicular bisector. First part is, we want to prove that every point on this perpendicular bisector is equidistant from these 2 points A and B. One thing. Second thing is A and B are two fixed point. Take a point P on the plane which is same distance from P and PB. Now you want to prove that PE will be fall on the perpendicular bisector of AB. After taking those two parts, we can conclude that the locus of point which is equidistant from two fixed points on a plane is nothing but the perpendicular bisector of the line segment joining them. Okay. Like that students, listen. Two parallel lines are given. What is the locus of a point which is equidistant from those parallel lines? Means just now we completed, no? That is nothing but another line which is parallel to both the lines and between them. Lines are parallel. A line is the point is equidistant from those two lines is nothing but another line which is parallel to given lines and between them. One thing. If two lines are intersecting, what happened? Two intersecting lines are given. We want to find the locus of a point which is equidistant from these two intersecting lines. We need to identify how. So for that I will explain the thing. For example, this is one angle, students, listen. This is A, O, B is one angle. Okay. Just draw the angular bisector. This, for example, is angular bisector, theta, theta. Take any point on this angular bisector. From that point, draw perpendicular on arms of the angle. So this is M, say this is N. Okay, students, listen, Nana. So theta, theta, 90, 90 and common. From A, S congruency, these two triangles are congruent. So what we will get, Nana? Pn equal to Pm. Pn equal to Pm. Means what I can say? The point P is equidistant from these two intersecting lines. Take one more point Q on the angular bisector. So draw perpendicular on the arms. With the same argument, you can say that these two triangles are congruent. Then you can say that P, some L and some K. PL equal to PK. From there you can conclude that Q is same distance from these two intersecting lines, say OA and OB. So what is the meaning of that? What is the meaning of every point on this angular bisector is equidistant from arms of this angle? That is important thing. Okay. One more thing. Take an angle, Nana. Now take a point P, so that it is equidistant from the arms. Equidistant from arms, given that these two are equal. So this is K, this is L, this is O. So this is A, this is B. Angle AOB given. Take a point in the interior of the angle, say P, so that P is equidistant from the arms of the angle. Then we want to observe where is that P, what is the location of P. I can say that P is nothing but a point on its angular bisector. But how to prove? Join PO. Okay, here 90, here 90. These two are same, this is common. Okay, from RHS congruency, these two triangles are congruent. From there what we will get, Nana? These two angles are equal. RHS congruent, these two are congruent. No, corresponding parts will be equal. Say this is theta, this is beta. Automatically theta equal to beta. Then what is OP? Angular bisector. So what is, this is say part 1, part 2. From part 1 and part 2, what I am concluding? The locus of a point which is equidistant from two arms of angle is nothing but its angular bisector. Is nothing but its angular bisector. Okay. By using this concept, you can compute this theorem, Nana. What is the question here? If two intersecting lines are given, what is the locus of a point which is equidistant from these two intersecting lines? Assume that this is nothing but a arm of one angle. These two are the arm of this angle. Automatically these two angles equal only, no? Because these two are intersecting lines. Vertical opposite angles are equal. So its angular bisector, every point is angular bisector, equidistant from these two arms, means every point is angular bisector satisfied by the given condition. What is the given condition? The points which are equidistant from two intersecting lines. Every point on this angular bisector is equidistant from L and M. Okay, students. Similarly, extend this. So every point on this angular bisector, every point on this line is equidistant from these two only, because this is angular bisector. Means what is the meaning of that? This straight line is the required locus. This straight line is the required locus. So what I can say? Two lines are intersect one another. The angular bisector formed by those intersecting lines is the one of the locus equation. Similarly, students, listen, important thing is, this is another angle, no? You can write its angular bisector. Every point on this line also satisfy the given condition or conditions. Okay. What is the meaning of that? If two lines are intersect one another, what is the locus of point which is equidistant from two intersecting lines? Means a pair of angular bisectors. Or in other words, I can say a pair of straight lines. Okay, one more important thing, student. This is theta, this is theta, this is theta, this is theta, this is beta, this is beta, this is beta, this is beta. This is a straight line only, no? Given line M is straight line, you know. 2 theta plus 2 beta, how much? 2 theta plus 2 beta equal to 180. Theta plus beta, how much? 90 degree. So theta plus beta 90 means what is the angle between this angular bisector and this angular bisector? 90 degree, no? What is the meaning of that? Two lines are intersect one another. What is the locus of a point which is equidistant from these two intersecting lines? Means I can say a pair of perpendicular angular bisector. A pair of perpendicular bisectors. Okay, a pair of perpendicular angular bisectors is the required locus. This is also one of the important theorem. So now I am finalizing what I explained here. Students, listen, two important things I explained. First one is two fixed points are given on a plane. What is the locus equation of a point which is equidistant from these two fixed points? Is nothing but the perpendicular bisector of the line segment joining them. One thing, one important. Next thing, if two intersecting lines are given, what is the locus of a point which is equidistant from these intersecting lines? Means a pair of angular bisectors which are perpendicular to one another. Okay. So this is the concept in plane geometry, Nana. But same concept we need to deal on coordinate plane. Okay, so you know what is meant by coordinate plane. This is our coordinate plane. This is called x-axis, this is the y-axis. To mutually perpendicular real number line divide the whole total plane into 4 equal regions called quadrants. Okay, this is called q1, this is called q2, and this is called q3, this is called q4. Okay, and one more important thing is every point followed by ordered pair on this coordinate plane. So what is the use of ordered pair on the coordinate? That is important thing. This ordered pair says the position of this point with respect to these two intersecting lines. One of them is called x-axis and another one is called y-axis. So what says this ordered pair? Ordered pair saying that this point is a unit from y-axis and b unit from x-axis. A unit from y-axis, don't confuse. Actually, a is called abscissa and b is called ordinator, or a is called x coordinator and b is called y coordinator. X coordinate saying that how much distance is that point from the y-axis. Y coordinate saying that how much distance is that point from x-axis. This is actually what Nana I can say b. So this is a. Actually need to write modulus distance, no. So what I can say, this is mod a and this is mod b. Distance from y-axis to that line is mod a. Distance from the point to x-axis mod b. Okay. So this is the definition of ordered pair on the coordinate plane. Okay. Locus means a set of points which are satisfying given condition or condition. That is one. Okay. But what is the meaning of locus on coordinate plane? So in plane geometry, we'll use the word locus, 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 locus. Locus is a circle. Locus is a straight line. Locus is a pair of straight line. Locus is a point. Locus is a like that. But here on coordinate plane, we'll use the word locus equation instead of locus. Locus equation instead of locus. Okay, both are same. Okay, but what are the difference of locus equation and locus? I will explain. Okay. Before that, students, yeah, now just now I explain locus. For example, a and b are two fixed points. Distance from them is 10 centimeters. Find the locus of p so that pa equal to 8 units and pb equal to some 4 units. Find the locus of point p so that p is 8 units from a and 4 units from b. 8 units from a. First of all, you need to find two conditions are given in this problem. Now we want to find our point which satisfies these two conditions. First of all, I want to find the locus of point which satisfies first condition. The point is 8 units from a with a as a center, 8 centimeters as radius. I can draw a circle. Every point on this circle is satisfied by first condition. Okay, understood? No? Okay, next condition. The point P should be 4 units from B. That's why with B as center. So actually, what is this? None. This 8. No. What is the remaining 2 actually? So with the B as center, 4 centimeters radius, I can draw a circle. Okay. Now what is the condition we want? Find out a point which satisfied by these two conditions. So take this point. This point satisfies only second condition. Take this point satisfies only first condition. But take this point will satisfy both the conditions. And what the locus means? I can say locus is 2 points Don't think locus is always a circle and a line, not like that. Locus may be a point, locus may be a curve. Okay, so in this example what I can say, locus is nothing but 2 points. Say this is a b already used, no, m and n. So here the locus is nothing but 2 points m and n. Understood? But for same problem, a b is given, same 10 centimeter. We want to find out the locus of point P, so that PA equal to some thing 5 units and PB equal to 2 units. Such a way that we want to find the locus of point P. First of all, try to find the locus equation which is satisfied by the first condition. The distance from P to A should be 5. With A center 5 centimeters radius, we can draw a circle. Every point on the circle is satisfied by first condition. Second, so here to here how much? No, 5. No, here to here how much? No, 5. Total 10. No, take B as center, 2 centimeters radius, draw a circle. So what are the common points satisfied with these two conditions? No point, no, because these two are not intersecting. So in this case I can say that there is no locus. Yeah, actual topic is locus equation. Yeah, students, our actual concept is locus equation. Locus equation, we mean finding out the relation that holds true between the x and y coordinates of all points on the locus. Okay, so I will explain. So first, for example, this is our normal plane, this is coordinate plane. Okay, so the question is, what is the locus of point which is equidistant from a fixed point O, or what is the locus of point which is 2 centimeters from a fixed point O? So what is the meaning of that? We identified all these points satisfying given condition. I can say that circle is the required locus, or I can say that a circle of radius 2 is the required locus. That we will write in words. The required locus is a circle with radius 2. But on coordinate plane, same question is given. Find the locus equation. Find the locus of a point which is 2 centimeters from a fixed point. Where is that fixed point? It may be here, or it may be here, or it may. Fixed point is not located. No. For example, this is a fixed point whose coordinates are given as 2, 3. Now we want to find out a locus of a point which is 2 centimeters from this fixed point. Obviously, here also we will get circle only. But you can't write answer as a circle here. So our answer should be by mean of algebraic equations. How to write? So what happened? All these points will satisfy condition. Now we want to identify a rule satisfied by all these points. One of the point on the required locus is taken as x comma y. One of the point. So this point also should satisfy given condition. What is the condition? Distance from that point to this should be equal to 2. Such a way that all these points will satisfy condition. A condition should be expressible in this small x and small y. What you will get that equation is called locus equation. Locus equation. Identify difference. Locus equation. Here simply we will write locus is nothing but a circle, locus is nothing but a straight line, like that. Here locus means x square plus y square equal to. Locus means some, just like we will write algebraic equations. Okay, now I will explain through this example, students. Let the fixed point is some k, let the variable point is p. Okay, so what is the condition? All these points are always 2 centimeters from this fixed point 2, 3. One of the point is taken x comma variable point. So P also should satisfy the same condition. What is the condition? PA should be equal to 2. So PK equal to 2. So PK distance between a point and to another point, you know how to find. So 2 equal to root over x minus 2 whole square plus y minus 3 whole square only. Or another way I can say that 4 equal to x minus 2 whole square plus y minus 3 whole square. So this is called the locus equation. Here what I can write? The locus is nothing but a circle of radius 2. Here what I can write? Locus, this is the locus equation. So means what the meaning of that? Every point on this curve will satisfy this algebraic condition, and every solution of this algebraic equation is a point on this curve. Okay, now again I want to read the definition. Locus equation, we mean finding out the relation that holds true between x and y coordinates of all points on the locus. Okay, I hope you people understood. Yeah, now how to find the locus equation? Steps should follow. These steps should follow. Students, once again I want to explain same thing. Find the locus equation of locus equation, not locus, locus equation of a point which is always 2 centimeters from a fixed point, some minus 2 comma 3. First, how to write step, that is important. And we can observe by, you can say answer now by observing this question. You can say answer is our curve is nothing but circle. Our curve is nothing but circle, because this fixed point is minus 2 comma 3. Variable point is moving such a way that always the distance from the point to the fixed point is minus 2 comma 2. But what should find here? You need to find what are the conditions satisfied by all the points. What is the step we need to take? A variable point is taken as x1 y1, not x comma y. In coordinate plane, x comma y is variable point, nana. X1 comma y1 is a fixed point. Okay. So first of all, let a fixed point x1 y1, okay, which is satisfied with the given condition. So first one, assume that the coordinates of the moving point be x1 y1. That one of the point is taken x1 y1. But how to write step? Let p x1 comma y1 be a point on required locus. This first step. After that, geometrical condition should write. Say this is say a condition. Condition should write. That is pa equal to 2. See here. Apply the geometrical condition on x1 y1, which gives relation between x and y1. So pa equal to 2. So pa means what? Root over x1 plus 2 whole square plus y1 minus 3 whole square equal to 2, or x1 plus 2 whole square y1 minus 3 whole square equal to 4. Okay, replace x1 by x and y1 by y in the resulting equation. Why am doing like that? I am generalizing this fixed point. No, I want generalize. So that's why instead of x1, what should write x? Instead of y1, should write y. So what should write at last? Therefore, the locus equation, or the required locus equation. That is better word. The required locus equation is x plus 2 whole square plus y minus 3 whole square equal to 4. Sometimes you need to simplify this. This is the locus equation. In this way, you can find locus equation of any point. Again, listen students. First, how to write the locus equation. Step 1. Assume that the coordinates of the moving point be x1, y1. Apply the geometrical condition on x1, y1, which gives a relation between x and y1. Replace x1 by x and y1 by y in the resulting equation. At last, the equation so obtained is taken as the locus equation, required locus equation. I hope everything understood the concept. Questions? One example problem. I can say example 1. The equation of the locus of the point equidistant from a minus 2 comma 3 and b 6 comma. 2 points are given, 2 fixed points are given here. One of them is a minus 2 comma 3. Another fixed point is given as 6 comma minus 5. Now we want to find locus equation, not locus, locus equation which is equidistant from these 2 fixed points. Instead of locus equation, simply a question is given. Locus means I can say that the perpendicular bisector of the line segment joining these 2 points. That is locus. But you want locus equation. We want to find a rule between x and y which is satisfied by all the conditions. Obviously, geometrically, I can say that this is the required locus. A straight line is the required locus. But what you want to find? What the common rule followed by all these points should identify. Let one of the point is taken as p x1 comma y1. I will write that. Let p x1 comma y1 be a point on required locus. That is the first step. So what is the second step? We need to write what is the algebraic condition. What is the given condition? The point should be equidistant from these 2 fixed points. That is, what is that? PA equal to PB. PA equal to PB. That is the condition. PA means distance from P to A equal to distance from P to B. So what I can write? Root over x1 plus 2 whole square plus y1 minus 3 whole square should be equal to root over x1 minus 6 whole square plus y1 plus 5 whole square. Now we need to simplify this. For that, squaring another side, what will get nana? X1 plus 2 whole square plus y1 minus 3 whole square equal to x1 minus 6 whole square plus y1 plus 5 whole square. Now more simplification, x square plus 4 plus 4x1 plus y1 square plus 9 minus 6 y1 equal to x1 square plus 36 plus minus 12x1. Okay, so plus y1 square plus 25 plus 10 y1. So some cancellation, x1 square, y1 square, y1 square. Now listen students, what I got I will write here. So minus 12x1 plus 16x1 minus 6y1, this is plus 10 minus 16y1. Yeah, what are the remaining things here? 4, 9, 13 plus 13, yeah, minus 25, what here something 41, 20, wait, yeah, here what happened, 4 plus 9 13 only, but here 36 plus 25, that is 61 equal to 0. At last you need to write conclusion. I will write the conclusion here. Therefore the locus equation, the required locus equation is 16x minus 16y minus, what is that, 61 20 means 41 plus 7 41 plus 48 minus 48 equal to 0. This is the required locus equation, or more generally you can divide through by 16, or that is I can say x minus y minus 3 equal to 0. This is the required equation of the locus, or I can say this is the required locus equation. Okay. Okay students, another problem I can say example 2. Find the equation of the locus of a point which such that its distance from 5 comma 0 is equal to the distance from the y-axis. Okay, listen, this is the x-axis and this is the y-axis. 5 comma 0, already you know that a point on x-axis, that is not big problem. 5 comma 0. Now on this plane a point is moving under some conditions. Let P is one such point, say x1 y1 is one such point. What are the condition? Find the equation of locus of point such that the distance from here to here distance, I can, okay, 1 minute, you people will confuse. Yeah, I will take here the point P x1 y1. Okay, the distance from 5 comma 0 to that, this distance equal to the distance from y-axis, here to y-axis, the distance here to y-axis. Already the distance from the point P to y-axis nothing mod x1 only, no? Indirectly given this distance, I can say this is A, say this is M. Indirectly given PA equal to PM. Distance from P to A equal to distance from P to the y-axis. What is the distance P to the y-axis? No? Point is given x1 comma y1, no? Automatically mod x1 is the distance from P to y-axis. So what should find? We want to find the locus equation satisfying the condition PA equal to PM. That I will write. Let P x1 comma y1 be a point on required locus. Okay, given condition PA equal to PM. PA means what? Distance from this point x1 minus 5 whole square plus y1 minus 0 whole square should be equal to mod x1. Squaring another side, x1 minus 5 whole square plus y1 square equal to x1 square. I can write mod x whole square becomes x square. Now x is 1 square plus 25 minus 10 x1 plus y1 square equal to x1 square. What happened here? x1 square get cancelled. So finally I will the locus equation, the required locus equation is, I want drop the suffixes, so that is y square minus 10x plus 25 equal to 0. This is the required locus equation.